Dear students, today we will discuss the assembly level language programming of 8051 microcontroller. Already we have discussed instruction set and addressing modes, everything in the classes, right? So the first program is assume that the RAM bit location 24H holds a status of PIR sensor to indicate whether there has been human presence or not inside the hall. First, you read the logic first time and twice, and you will try to get the what is the problem statement it is given for you. Write a 8051 assembly language program to set port 1.0 bit as high if 24 bit memory location, that is a bit location, is high, that is a RAM bit location is high. If it is low, set port 1 point bit as low. So first I will say, oh, what is the logic they have asked. See, what they asked is, so this is there is in the program they specified the bit location, that is a RAM bit location 24H. Here you need to understand from 20 to 22F all are bit addressable location. So I can assess the each bit with their address. Here what is the address? The specified 24H. So what they are saying, if this 24 address location hold high, see, if 24 hold high, so what I need to do, I need to make set port 1.0 as a high. If this is low, that means 0. If this bit location holds the data 0, that means I want to make the port 1.0 as a low. That's it. This is the coding I need to understand. Before that, let me give very short important note. We know that we have a 4 ports: port 0, port 1, port 2, port 3. All are 8 pins, right? 8 pin, 8 pin, 8 pin, 8 pin. Totally 32 pins. We can assess through byte accessible. That means I can assess the 8 pins at a time, right? If I can use also like a bit accessible also. Bit accessible means in the particular port I can assess the individual bit. So how many bits are there? You have a 8 bit, that means 0 to 7. So here I can write the syntax for bit accessible like P x point y. X represent the port number, that is ranging from 0 to 3, that you are clear. The y represent, that is a bit number of port ranging from port 0 to 7. Suppose if I want to access port 1.2, that means what is the condition? In the port 1 I need to access the bit number of 2, right? That, so similarly I can access for any ports, like for port 0 or port 2 or port 3, I can access the bit access. Okay, I can access the bit number of the ports, that is ranging from 0 to 7. So the range 0 to 7, that is 8 bit. Okay, here I am using port 1.0, that means in the port 1 I am accessing the 0th bit, right? 0th bit I am accessing. Okay, so now we will start the program. So I hope the logic is clear. So this is a bit addressable location based, the memory location is given for you, right? So we will start the program org00h. Another important thing, see, when you see the next instruction move p1 comma hash 00h, that means hash immediately says that is an immediate value. What do you mean by 00? So if I am saying port 1, like a 0 0, that means I'm specifying, I'm configuring the port 1 as a output. If I'm saying FFH, that means I'm configuring the port 1 as a input. What do you mean by FF? That is 1 1 1 1 1 1 1, right? 1 1 1 1 1 1 1, totally 8 bits. That means 8 pins also I can configure as a input pins. Another important thing, if you are configuring a specific port 1 as a output, it is not mandatory to write in the program. Only in the case of specifying the input, you need to specify FF. That means you are configuring a specific port as a input ports. Okay, so we'll come to the next line, that is label. Move C24. 24H is your memory address location. It's a bit location. Where is that? This is a 24th. Now I want to check. So we need to give the input, right? So if it is 1, I'm just considering 1. That means it will come to the next line. Jump if there is no carry. So here you can see you have a carry, right? That means it will skip this line. So and it will go to the next line. If you have a 0 only, it will execute this instruction, otherwise it will skip, because jump if there is no carry, but you have a carry, right? That means you want to go to this instruction. And what I need to do, I said, right, if you see is 1, what I need to do, I need to make your port 1 as a high. That means how you will make for individual port, for individual port you need to keep set B. Set B means you are making the individual port, the specific pin as a high. That is set B port 1.0. Then short jump again, so it will come to this label again, and again it will check that memory location. If I am giving 0, just assuming if I am giving 0, what happened now? This will execute. So jump, there is no carry, so no carry, right? So what it will do, it will go to the no label and will execute this. Why you need to clear? Because the logic is, if it is low, I need to make it the 1.0 so low, so I am clearing the port 1.0 so that it has a low. Again, after completing this instruction, short jump again it will go here and will check the 24th bit location. It is a continuous process and end the program. So next program is write an assembly language program to count number of ones and zeros in a 8-bit number. The logic here is you need to store the number of ones. That is, you want to count in the 8-bit number, you want to count how many ones and how many zeros. So you want to count the number of ones and you want to update in the register R1, and number of zeros you want to count and you want to update in the R2. This is a logic. So first I am initializing all the registers. I am taking two registers R1 R2. So move R1 comma hash 00H. That means I am initializing the R1, the register is a 00. Similarly for R2 I am sending the immediate value 00. That means the current data for R1 is 00 and R2 is 00. Right. Then move R7 08H. Why given? Because I want to do the counter for 8 bits. I need to check the 8 bits. So that's why I initialized your R7 as a 08. Okay. 08. Right. Now the next is I'm sending a transferring 97 immediate value to A, right? So 97. So 97. How you will write? 8421. 1 0 0 1 0 1 1 1. Okay, here in this 8-bit number I want to count number of zeros and number of ones. Okay, that is a logic. Okay, now what I am doing, rotate left along with the carry. Okay, so this is your data, right? 1 0, whatever accumulator hold, that I need to rotate with the left side along with the carry, right? So G1 0 1 0 1 1 1, right? So what is the carry? Carry will be initialized, will be 0. So I need to rotate in the left side. Okay, so now rotate left along with the carry. Okay, so once I execute this instruction, what it will do, so it will come, this will come here, that means 1, carry will be updated as 1, and 0 0 1, this 0 1 1 1. So already you have a 0, right? So that will come this side, 0. Okay, so now I will check jump carry next. So this is 1, right? That means it have a carry. So where I need to go, I need to go to the label next. So next, I before R1 was 0, right? So that means I have a 1 once, I have detected 1 1. So now I need to update as 0 1, right? So now decrement jump if no 0, right? So what is the R7? R7 I need to decrement. So now you need to decrement, you will make as a 0 7. So it is non-zero, right? If it is 0 only, it will come outside from the instruction. It is non-zero, right? Again it will go to again. So that is a label which is given. So now again you need to rotate along with the carry. So if you rotate along with the carry, what will get? So you will, this will come here, 0 1 0 1 1 1 0. This will 1 come to this side, right? 1. Okay, now you can see carry is 0. So it will check jump if you have a carry. So there is no carry, right? So what you need to do, it will skip this instruction and it will go to the increment R2. What is R2? Before it was 1. Before it was 0, now it was incremented to 1 because of this instruction. Now short jump here. Okay, so short jump here means where it will go to here. So again it will check the R7. That is a counter we have assigned, right? Before it was 7. Now you want to decrement 6. Whether it will check is it 0 or non-zero. It is non-zero, right? Again it will go to the again loop. Again I want to rotate this accumulator along with the carry. So that means what? So I need to get 0, right? So 0 and 1 0 1 1 1 0 1. This 0 will come to here, right? It will come to here. So now again it will check. So you have a carry, no carry. So where it will go? It will go to this. If you carry only, it will go to next. Otherwise it will skip and go to R2 and increment the R2 with the present value. So it was 1. So now it will become 2. Similarly, it will count for upcoming values, right? So the next value, how it will come? Again, what happened? This one will come here and 0 1 1 1 0 1 0. What is the carry? Carry was 0. Again, this is the carry, right? So it will come here, right? So this we have a carry now. right? So this is your 8th rotation, this is your 7th, this is your 6th, and this is your 5. Similarly you need to do for 4, 3, 2, 1. So if you do it for this many rotation, your your R1 and R2 register will be updated. So how many will be getting? So number of ones is 1, 2, 3, 4, 5. So R1 will be holding 5, and 1, 2, 3. Your R2 will be 3 after execution of this instruction. Okay, so here the main instruction is RLC. You want to rotate left side along with the carry. So that means if we say this 1 0 0 1 0 1 1 1, consider carry is 0. Okay, so you want to rotate along the left side and you want to bring this carry to this side. Okay, so this is the logic of this program.